So today's lesson we are going to study similar triangles. The reason why we want to study similar triangles because in real life you see this is on Google map and you see this is city of Barrie. We can zoom out, zoom in, and it doesn't matter how we zoom in, zoom out, the shape they are same, just the size will be different. So each one, if it's a trapezoid, then we zoom in, it will be still trapezoid. Okay, and the house, if it's rectangle, then you zoom in, it's still same size, shape, but different size. We call them similar figures. And the map is a scale drawing. Okay, this one we call scale drawing. The shape is not going to change, but the size will be changed. And you see the similar shapes, similar figures, all the scale drawings. You could see it everywhere in real life. And your family picture, you enlarge it, you want to hang it in your room, then that is a similar figures too. And there are so many figures too complicated, and as mathematicians we are going to, they want to use a simple list of shape, that is a triangle, to do the study, to find the properties for similar figures. Then in future we can apply those properties for all scale drawings. So that is the reason we want to study similar triangles. And now we are going to see for these similar triangles, we have two of them below. They have the similar shape, the same shape, but different size. And we label them triangle ABC and triangle DEF. So we say triangle ABC and this sign like the eyes but rotate. Then we call it similar. And this is a sentence. Triangle ABC is similar to triangle DEF. And if we write two triangles are similar in this way, be careful, order is important. So first letter correspond first letter. So A correspond with D. And in the triangle is angle A correspond with angle D. Angle second one, angle B corresponds with angle E. And the last one, angle C corresponds with angle F. And now I want you to get a protractor out. If you have one, and I have put protractors on your desk, so get it out. We want to measure the angles. Measure those angles, and I have a protractor here. I hope it will work. And I want to put it, measure angle A, and how to measure the angle A. You need to rotate it. So I just rotate it to, okay. Put the center of the protractor overlap with the angle A. Then you rotate this one, make sure these 0 angles align with one arm of the angle A. Okay, this is a one arm, this is a second arm. Then we are going to read from 0 up. We find out, okay, that is 20 degrees. We don't use outside the measurement. Outside is 180, so it start from 180, then smaller. We want to start from 0. So read the inside. And if you flip your protractor, then you are going to read outside. Okay, so it depends how you put your protractor there. So what I mean is, okay, so if you use another way, then it will be go another side. So now we are going to write it here. Angle A is 20 degrees. Make sure the center of your protractor at A, this point, the vertex, at this vertex, okay? And one side of the protractor starting line, the 0, 1, lay over with one arm of the angle A. Then we are going to count from 0 up how many degrees to get to the another arm of angle A. Then from the reading, we could see that is 20 degrees. Okay, so this is 20 degrees. It's from here to here. Then we are going to measure, maybe just continue angle B. So just do it. Remove this one. Center at here at B. Then we are going to rotate. Okay, sorry. We could just stay here. We don't need to move. Okay. So we just put this one here. Then we are going to see this line is overlap with one arm of angle B. Then we are going to see the measurement of angle B. We are going to use the outside the measurement. Okay, start from 0. Then we are going to count 100, 110, 120. So you will see this arm is 120 degrees. From 0, we count to 120. So this time we use the measurement on the outside, not from 180. Okay. So now we will know that the angle B is 120 degrees. 120 degrees. Then we are going to measure angle C, and actually I believe you should know that what angle C is. So I will just align, turn it a little bit, then put the center at the vertex of angle C. Then we are going to turn it a little bit, make sure one arm is aligned with 0 degrees, okay, with the bottom of this protractor, okay, they overlap. Then from angle B, we go up. It will be start from 0. We don't use 180, then go back. The angles should go up. So from 0, we go up and see it should be 40. So we have human arrows, so that's the reason it's not exactly. So I will move it a little bit. Move it a little bit down. Then, okay. Okay, so now it's 40 degrees. The reason why I want to remeasure it, because we have a rule that is the sum of these 3 angles should be 180 degrees. So that's the reason we are not going to have other numbers. And the reason why it's off a little bit, because when we are doing measurement, we have human arrows. Okay, so we have done for the first triangle. Now we are going to do it for the second triangle. So we turn it, put the center at angle D, center at the vertex of angle D, then continue rotate. Okay, then we are going to measure angle D. From here to here, we start from 0, 10 degrees, 20 degrees. So angle D, after we do the measurement, is 20 degrees. So Amy, pause here and please measure the angle E and F by yourself. And now I will show you. So we just move this one all the way to angle E. Then you are able to see from 0 all the way, count here. It will be 120 degrees. So because human arrows, sometimes it may off a little bit. So to here is 120 degrees. Now we are going to write it down. And I will remove this one. Okay. So 120 degrees, and the next one is 40 degrees. So now you have found one pattern for similar triangles. The corresponding angles are equal. So we label this property on the graph will be, we could use same symbol for equal angles. So single arc for these two angles equal, double arc for angle B and angle E. It means angle B equals angle E. And also we could use triple arcs here, or we could just use a dot. It also means, okay, these two angles are equal. If you see on the questions, you have same symbol on two angles, it means that two angles are equal. Okay, so next one, pause this video and measure the side. Use a ruler. And I will show you that after measurement, what the number will be. So I have some numbers here. You will have some measurement maybe a little bit off from these numbers because human errors. Okay, 4.8, then 8.0. This one is 6.5. This is 11. This one is 2.5. This is 4.5. So your measurements may be a little bit off from this one. These are not the accurate one too. Okay. Now we are going to find the ratio of the corresponding size. Okay. So 8.0 divided by 4.8. You will have the number is 1.66. And 11 divided by 6.5, it will give you 1.69. And the last one, 4.5 divided by 2.5, it will give you 1.8. So they are not exactly same, but if without human errors, they should be equal. Okay, so the rules, now we figure out two properties for similar triangles. One property is, so it's this one, not this one. Okay, one property is the corresponding angles are equal. Okay, so the first property for similar triangle will be corresponding angles are equal. And also that is the reason why order matters. When you are writing the similar triangles, make sure the angle equals must be at the same order. Okay, angle A equals angle D, angle B equals angle E, angle C equals angle F. And the second rule, although we don't have the same ratio, but if we could measure it more accurately, then you should be able to get all the ratios are equal. So another property is corresponding ratios are equal. So it's easier to understand. If you have one triangle, then you just zoom it double, then, sorry, if they have the same shape. If you double it, then before the side is 1, then all the other side will be doubled. So that is the reason if you have the same shape, then if one side is doubled, then all the other side need to be doubled in order to get a similar shape. So that's the reason corresponding ratios are equal. Ratios means division, divide. Okay. So these are the two properties, and these two properties we could apply to all similar figures, not only for similar triangles. And we want to focus on similar triangles first. So in order to prove that two triangles are similar, you have several rules. So side, it means if you have all the corresponding ratios are equal, then the two triangles will be similar. So SSS means each ratios. So 3 corresponding ratios are equal. Corresponding side, corresponding ratios. It means sides divide each other. Okay, ratios are equal, then for sure we know the two figures are equal. Just like I give you one example. This divided by this side is 2, this divided by this is 2, this divided by this is 2. So we know this one is enlarged by 2. So they have the same shape. And the second condition you could use to prove two triangles are similar is side angle side. So it means if in the two triangles you have corresponding this side divided by this side equals this side divided by this side, and also the contained angles are equal, then if you form a triangle, then they will have same shape. So this is for the second conditions. So two ratios are equal. Two ratios are equal, and the contained angle. Contained angle, so the angle between the two sides are equal. Contained angle are equal. Angles are equal, then the two triangles will be equal, will be similar. And the last one is if in a triangle you have two corresponding angles equal, so you have this angle equals this angle equals this one, then for sure the last one will be equal, because 180 degrees minus these two angles then we'll give the last angle equals. So for two triangles, if you have two corresponding angles are equal, then we could prove that the two triangles are similar. So the last three conditions, you could use one of it to prove two angles, corresponding angles are equal. So two corresponding angles are equal. Means two pairs, okay? Two corresponding angles are equal, then we could prove the two triangles are similar. So the first page has covered everything you need to know for today's lesson. Today's lesson you need to know is rules of similarity. So corresponding angles are equal, corresponding ratios are equal. And how you could prove two triangles are similar. One is you measure the three sides. If the three sides, you divide the corresponding sides, then the division value, they are equal, then the two triangles are similar. Or if you have two triangles, you measure one angle, they are equal, and the size for that angle, the ratios are equal, then these two triangles will be similar. And the last one is in a triangle, in two triangles, as long as you have two corresponding angles equal, then these two triangles will be similar. So this is important properties for triangles, but also it could be applied. These two properties could be applied to all similar figures. The important properties for similar triangles. Then we are going to go to next page and see how we are going to apply them to find the unknown variables. So in math all the time we are looking for the solve for the unknown variables. So in example 1, we have triangle ABC similar to triangle PQR. Remember, order matters. So now I want to, based on the order, and label these two triangles. So angle A corresponding to angle P, angle B, use double arc, equals angle Q, and angle C, triple arc, equals angle R. Okay, so it asks you to find the measures of angle B, angle C, and angle P. So these two equals, so angle A equals 99, then angle P equals 99 degrees. And angle B equals angle Q, so angle Q is 26 degrees, then angle B is 26 degrees. Angle C equals angle R, so angle R is 5 degrees, then angle C is 55 degrees. So by applying the properties of similar triangles, corresponding angles are equal, then it's really easy for us to find the unknown angles. So we rewrite it here. Angle B equals 26 degrees. Angle C equals 55 degrees. Angle P equals 99 degrees. So the first question is solved. Question 1a is solved. Then question 1b, it asks you to find the side x and the side y. So it's hard for us to see which side corresponding. So we could use the first two letters AB. So the first two letters is AB. Then our first two letters is PQ. So these two sides are corresponding. So we would like to write the corresponding ratios are equal in order to solve for the unknown side. So we are going to write first two over first two. So side AB over corresponding side PQ. Then we are going to do the last two letters BC. BC is this side over last two letters QR. So these two sides are corresponding. Then we write BC first. The numerators should be from the same triangle. So BC over QR. BC over QR. Ratios means division. Then we still have the last side left. So AC over PR. Or we could see it from these letters. First and the last is the AC side. First and the last PR is this one. So then from the first two letters, last two letters, first and the last letters, first and the last letters, it will be easier to find the corresponding side. So over PR. Then, so we use the first important property for similar triangles to find the corresponding angles. Use the corresponding angles are equal to find the angles. And the second question 1b, we use the ratios. The corresponding ratios should be equal. So from this to this graph, if one side doubled, then all the other sides should be doubled. So that is what it means. The corresponding ratios should be equal. So, and after that, we are going to substitute the given information into this equation. So it will be AB equals 6. So it will be 6 over PQ is 9. Then equals BC is X is unknown. Then QR is 12. Then continue, AC is 3. PR is Y. Then you will see we substitute given information into this corresponding ratios are equal. Then we have 3 ratios, 3 divisions, they are equal. And we want to solve for X and Y. I mentioned before, in one equation, we need to have only one variable. So one equation means you have only one equal sign. So we are going to pick 2 ratios to put it at left side and right side to set up the equation. So in order to solve for X, which 2 ratios are we going to pick? We need to use X over 12. For sure, we need this ratio, but we don't want to use 3 over 1 because if we use these 2 in one equation, we are going to have 2 unknowns. We don't know how to solve 2 unknowns in one equation. And this ratio, both numerator and denominator are given, so we are going to use both numerator, denominator given, use this ratio. Then you will see in this equation we have only one variable. And in order to solve for x is at numerator, you could just times 12 to other side. All I want to show you, you just use cross multiply all the time, then because you just have one fraction one side, another fraction on other side, then we could do this cross multiply. I put the cross, then after that the multiplication, the operation will be multiplication. That is the reason I call it cross multiply. Okay, so cross multiply. So these arrows represent times. So we are going to put x on the left side. So 9 multiply x at one side. And another cross, put it to other side. So 6, 12, cross multiply is times. Then you have this equation, you have only one x you need to solve. We are going to move the 9 to other side by doing opposite operation. So 9 times x, move to other side, will be divide. Then 9 divided by 9 give you x. 6 times 12 divided by 9 give you 8. Then you got x solved. Then we are going to do the same thing to this one. So this one we are going to do it is use a 6 over 9 with 3 over y. Then you will see in this equation you have only one variable unknown is y. Then is a fraction one side, fraction other side. We could apply the use a cross multiply. So the arrows represent cross and operation is times. So we are going to put y on the left side first. It will be 6y. Then equals cross 3 times 9. Then we want to solve for y. We don't want to see the 6. 6 times y, opposite operation will be divide. Then you will have y, 6 divided by 6 is 1y. Then it's 1, then times y equals 3 times 9 divided by 6. It will give you it will be a 2, 9 over, so 3 over 6 is half, 9 half is 9 over 2, or you could give 4.5 in decimals. So example 1, we have used corresponding angles to find the unknown angles, and we have used corresponding ratios are equal to solve for the unknown side. When we are using the corresponding ratios, you need to pick two ratios to set up one equation with one equal sign. Then we could use cross multiply. We put a cross here, then at the end of this arrows of these two numbers times together to put one side, then the cross the other two numbers times together put at the other side. Then this is a linear equation. Then we isolate x by move the numbers to other side. Then you got the answer. So example 2 is they ask you to see if the triangles are similar. State your reasons. This is called prove. So how to prove it? We have three conditions: set side, three sides corresponding ratios equal, then they are similar, or side angle side. So one angle equal, other two sides the ratios equal, then it will be similar, or angle similarity. So if you have two angles, corresponding angles are equal, then it will be similar. So we are going to see for this one, okay, angle B equals angle N. We have one pair of angles equal. Then we are going to see if we could find other corresponding angles equal. So this one, you have 28, 82. We want to find this angle. So in order to find this angle, we are going to apply the sum of interior angles for a triangle is 180 degrees. So we find angle A will be 180 minus these two angles. Then we do the calculation, you will find out it's 70 degrees. Then you are going to see this, none of the 65 is not equal to any of them. You have only one corresponding angles equal, so this is not. No, they are not similar because state your reason. You are going to write here because only one corresponding angle is equal, then they are not similar. Okay, so it's not similar. And for the next one, you have the no angles given, then three sides given. So we are going to see if we could use side, side, side corresponding ratios equal. Then when we decide the corresponding ratios, you need to determine which two sides are corresponding. So the rule is longest to longest, okay, corresponding, and the shortest divided by the shortest. So longest to longest will be corresponding. So in this one, the longest is 8. In this one, longest is 12. So these two sides are corresponding. So we are going to do the division 12 over 8. Then check. Use your calculator, you will find out it's 1.5. Then we are going to find the shortest side. So 4.5 is shortest. This one, 8 is shortest. Then we are going to do the, always if you use 12 as numerator, then the next ratio you must use the side in the same triangle. So we use 8 on the at the numerator, then divide by 8.5. Then you do the calculation, you are going to find. So we are going to use calculator on Dirt Math. So it's 8 divided by 4.5. Then enter. It actually is here already, 1.77. So 1.77, then you will see they are not equal. So no, they are not similar because the corresponding ratios are not equal. Ratios are not equal. Are not all equal. Okay, so this is the two examples to show you how are you going to show the triangles are similar or not. Then the next one is because we are studying triangles. So for triangle, the special triangle, right angle triangle has a very important property. It's Pythagorean theorem. So we are going to see how in one single triangle, how are you going to be able to find the unknown side by using Pythagorean theorem. So Pythagorean theorem, the C is always the longest side. So we could label this one as C, this is A, this is B. Then we sub in the given information to the Pythagorean theorem. You will have x squared equals 8 squared plus 6 squared. Then x squared equals to the calculation, you will find out 8 squared is 64. 6 squared is 6 times 6, give you 36. Then we have x squared equals 100. And we want to solve for x. We don't want to see the squared. The opposite operation to squared is square root. So get your calculator on you can use a calculator on DirtMath. We are going to say squared, then 100. Then it has equal 10. So this is 10. X equals 10. Then it's done. And actually, whenever you square root a number, you should have positive and negative sign at front. But for the measurement, we don't have negative 10 centimeter. So for measurable this length, we don't have negative. So that's the reason we ignore the negative. Then you will have positive answer only for the length. So we do the same thing, and C equals A squared plus B squared. C is always the longest side. So this is, you could switch A and B, it doesn't matter. Then we sub in, you will have 10 squared equals x squared plus 3 squared. And we want to solve for x. We want x by itself at one side. So we want to move the 3 squared to other side. 3 squared is 9. Plus 9 move to other side give you minus 9. So 10 squared, I will write it again, minus 9 squared equals x squared. Then use your calculator is 10 squared, 10 times 10 give you 100. 3 squared give you 9. 100 minus 9 equals x squared. Then it's 91 equals x squared. We move the squared to other side will be square root. Then you have positive, negative at front. So always when you square root something, you should have positive, negative as your solution. Then we ignore the negative, you will have x equals square root 91. You could write it in decimals, so we just square root 91. The equals is, sorry, I need to restart a line. Square root 91 equals 9.539. So we could keep one decimal places. So 9.39. 9.5. Okay, we just keep 9.5. It's okay. The 3, we could round it off. It's less than 5. So you keep the answer. If it's one decimal, just 9.5 is good. Then centimeter. This is a tens. So this is the nearest tens. So this is answer for this side. Next page, we are going to do more practice on solving similar triangles. Solving similar triangles means we are going to find the unknown values. So this one, I want to pause the video and ask you to try it by yourself. Try to find the unknown values. It means you are going to find all the value angles of side that not given. So for example, this angle not given, you need to find it. And this angle not given, you need to find this one. And also this angle not given, you need to find this one. And for these two sides given, this one not given, you need to find it. These two sides given, this one not given, so you need to find this one. And try to do this one by yourself, then you are going to have 5 minutes, then we are going to take it up. Okay, so now we are going to see triangle ABC is similar to triangle RST. So angle A corresponding to angle R. AR. So now we know angle A equals 21 degrees. Then angle B equals angle S. So angle B corresponding to angle S. So 3 arc. Then we know angle S equals 118. So I will erase this one, it's hard to see. So 118 degrees, or you could just write inside the triangle 118 degrees. Then we have angle T unknown. Angle T is corresponding to angle C. So angle T is corresponding to angle C is double arc. That equals 41 degrees. Then we have solved all the unknown angles. And after that, we are going to solve for the unknown side. So we may label this one with X, this one with Y. And in order to find the unknown side, we are going to write out the corresponding ratios. So I have shown you that first two letters, that is one side, corresponding to the first two letters, RS. So if we write the ratios out, will be 10 over 16. So we may write the letters first before we sub in the given information. Okay, so AB over RS. RS, that is two letters for one side. Then the next two letters, the last two letters will be BC, ST. So BC corresponding to ST. Then we are going to write this first. So BC over ST. Then we have only the last side left. So you could do first, last, or you just write whatever left for the last ratio, so RT. So we have these three ratios equal. The next step, we are going to substitute given information into this ratio. So AB is 10. RS is 16. So first ratio is 10 over 16. Then equals next ratio. BC is X. ST is 5.3. AC is 12. RT is Y. Then we have these three ratios are equal. One equation, we want to have one equal sign, not two equal signs. So we need to pick two ratios to set up an equation with only one unknown. So we want to solve for x. We want to pick the ratios. Both numerator and denominator are given. So we are going to pick the first two ratios to solve for x. So I will rewrite the ratios here. So 10 divided by 16 equals x divided by 5.3. So we could use a cross multiply, or you could, when the x at numerator, you could just move the 5.3 to other side by doing opposite operation. This is x divide, then it will be times. So, but in order to avoid any mistakes made, we are going to do the cross multiply. So 16 times x, this cross means multiply, so it times is 2. Put it at one side. Then this is another cross. Then it's 10 times 5.3. So cross multiply is cross and times. Then in order to solve for x, we want to move the 16 to other side. 16 times x, move the 16 to other side. We do the opposite operation. It's division. So divided by 16. Then we are going to use a calculator. Is 10 times 5.3 divided by 16. Then equals is 3.3. So x equals, continue. This arrows just means that my solution is continue here. X equals 3.3. That is done for x value. Then we need to find the y. We want to find the y. We still use a given ratio. This both numerator and denominator are given. Then we use this one. Then this is one fraction, another fraction on other side. We could do the cross multiply. So cross then times. Cross 10y, so 10 times y equals this cross times 16 times 12. Then we move the 10 to other side by doing opposite operation is division. Then get your calculator out. You will have 16 times 12. 16 times 12 divided by 10. Then you have the answer is 19.2. And put unit here, centimeter. This is a centimeter. Then it's done. So check your answer to see if you got it correct. And if it's needed, you could rewind this video and watch the steps again. Okay. So now is next one. So the following pairs of triangles are similar. Find the unknown side again. So now give your time, then pause the video, do it, and check the answer. So now we are going to do this question. I think this one is wrong. It should be at this side. Okay. So for this one, you will see it's not labeled with letters for the vertex. So we are going to label it now. The reason why we want to label it, because we want to use a triangle similar with triangle, then the corresponding side ratios are equal. If we don't label it, then we don't know which side to which side is corresponding. So we label this one, then we know, okay, angle B equals angle E. So B and E is corresponding. C and F corresponding. These two angles equal, then A and D will be equal. So A and D will be equal. Then we write similarity here. It's similar with this one. As long as you have two corresponding angles equal, then the two triangles will be similar. Then the reason why you put triangles at front, okay? Why we want to write it in this way? Because once we have it in this way, then it's easier for us to find the corresponding side. AB corresponding to DE. So AB is corresponding to DE. Two letters for one side. So we write it out. AB divided by DE equals the last two letters BC, EF. BC, EF. Then equals BC is 8. EF is Y. Sorry, I need to write it in letters first, then substitution later. Okay, so BC over EF. Then you have one side left only, so AC over DF. Or you could, from this one, first letter, last letter is AC, first letter, last letter is DF. So it is for the last ratio. Then after that, we are going to substitute given information into this equation. So AB is 11. DE is 15. BC is 8. EF is Y. Then equals AC is X. DF is 14. Then we have these three ratios here. Now we are going to set up equation and find X and Y. So these both numerator, denominator are given. We are going to use this ratio. Then set up one equation for Y. So 11 over 15 equals 8 divided by Y. Then we are going to do cross multiply. So 11 times Y equals cross times 15 times 8. Then move the 11 to other side. You will be able to find the Y value. It's 15 times 8 divided by 11. So 15 times 8 divided by 11 then equals 10.9. So 10.9 that is done centimeter. Then we do the same thing for X. So we set up equation for X. 11 over 15 equals X divided by 14. Then we could do cross multiply, or we could just move the 14 to other side. If your X is at numerator, you could just move the 14 to other side. This is division, you move it to other side will be times. So 14 times 11 over 15 equals X. This only applies when X at numerator, okay? If X at denominator, then you are not able to just move the a to other side, you times it. It doesn't work that way. So you need to do cross multiply if it's denominator, the unknown. Then we do the calculation is 14 times, so we need to 14 times 11 divided by 8. Then you have 19.25. Sorry, divided by 15. So it's not right. Just delete and okay, 14 times 11 divided by 15. Then you have 10.266. We want to keep one decimal places, the next digit is 6. If the next digit is 5 or above, you are going to round up by adding 1 to this digit. So it will be 10.2 plus 1 is 10.3. X equals 10.3 centimeter. So this is for this question. Then the next question, please try it by, I may not ask you to try it by yourself because it's a little bit different from others. So this one is not two separated triangle, it's together. So you could see this triangle like two triangles. One is PMN and another one is PQR. So you have two triangles, they just overlapped each other, okay? So this parallel means from the F pattern, these two angles will be equal. And these two angles will be equal. Then you will see in these two triangles, two corresponding angles equal. So these two triangles will be similar. This angle should be equal. Then we write the two triangles similar will be PMN, similar to P corresponding to P, M corresponding to Q, N corresponding to R. Then you have these two triangles are similar. So I need to rewrite this one. So triangle PQR, they are similar. And how we get this conclusion because angle corresponding angles are equal, so it's angle similarity. Then once we have these two triangles are similar, then we want to label this triangle with PM is 4.2, PQ is 12.6, MN is 4.6, PN is 5.2. It asks you to find QR, asks you to find PR. So we are going to write the corresponding ratios out by using first two letters over first two letters. So PM over PQ. So it's PM, yeah, this side equals this side. Then equals the last two letters over last two letters. The two letters represent one side. So MN is this side. And this QR is this side. So MN over QR. Then we are going to do the last one is whatever left. So this side PN over PR. Also, you could see it's the first letter, last letter put together is your last side. Once we have these three ratios are equal, we are going to substitute given information into these ratios. So PM is 4.2. PQ is 12.6. MN is 4.6. QR is X. PN is 5.2. PR is Y. Then we are going to do the cross multiply. So set up using the ratio, both numerator and denominator are given to solve for the unknown. So use this one, set up equation. 4.2 over 12.6 equals 4.6 over x. Then the x is not at numerator, so we cannot move the 4.6 to other side. Then isolate x. We couldn't do that. We need to do the cross multiply. So 4.2 cross multiply with x give you 4.2x equals 12.6 times 4.6. Then in order to solve for x, we move the 4.2 to other side by doing opposite operation. Then we are going to use our calculator, 12.6. So 12.6 times 4.6 divided by 4.2. Then it gives you 13.8. So we have x equals 13.8. So that is done. It didn't write units, then you just leave it blank, it's okay. Then we do the same thing to the y. And also here, I want to show you another way to do this one is a scale factor. Scale factor is focus on one ratio, okay? One ratio is we want to use 12.6, the larger number divided by the small number, then you will see it is 3. Then we know that from this triangle to this triangle is enlarged by this scale factor 3. So in order to find the unknown side for this bigger triangle, we could just times that 3 to each side. Then we are able to find the answer. So that is another method you could use is find the SF scale factor, scalar. Once you have this scale factor, then from the smaller triangle to bigger triangle, we could just times this one. So we use a bigger triangle divided by small triangle. Then from this one to here, we know this is a times by 3. Then all the corresponding side just times by 3, you will get the unknown. So we are going to just repeat for x. X is 4.6 times by 3. Then you will have 13.8 right away. And for the y, it's just this side, 5.2 times y. 5.2 now times y times by 3, you will have y equals 15.6. So this is a called scalar method. So it's another method you could use, okay? Scale factor method. You could use this one, but just make sure you need to know this is a bigger triangle divided by a smaller triangle because then this number will be bigger than 1. Then you are going to, from small to big, you times it. From big to small, you divide by that. So you need to make sure you could be able to tell, go this way times and go back, divide by 3. So if you find backward, you need to divide by 3. Okay. So this is what we have done for today. Today we have learned the important rules for similarity is for similar triangles, the corresponding angles are equal. That is the first rule for the similar triangles. The second rule is the corresponding side. You divide them, the ratios is division are equal. Then for solving unknown angles, we just use corresponding angles equal to solve for the unknown angles. And for solving side, you need to set up the corresponding ratios. Then pick 2 ratios to set up one equation. If the x is not at numerator, you are going to do cross multiplying, then find the unknown. Or you could use a scale factor. The scale factor is you just pick the given ratio, try to use a bigger number divided by the smaller number, then you will have a number called scale factor. Then from here, we are going to, from small to bigger triangle, we times that number from bigger triangle to find the smaller triangle, then divide by that. So that is all for today's lesson and today's homework. Again, paper pencil work, but make sure you have exit ticket. You need to finish on 30 miles. Okay, exit ticket on 30 miles each day. So you need to make sure you get this one done. And also you need to do the practice test on 30 miles. Friday, we are going to have our cycle 1 test on 30 miles. Starts at 11 a.m. And morning will be work period, so prepare for that cycle 1 test. Thank you.